everybody. My name is Robert Douglas. I'm the Chief DevRel Officer for Platform.sh. It's always a interesting conversation starter what the SH stands for, and I usually tell people it's correctly pronounced platform, but it emanates from a insider joke, SH, of course, being the extension that you would put on a bash script file in your Linux file system. We thought that would be a kind of a something cute for developers to identify us as their type of service. Not sure it really worked, but there we have it. We're Platform.sh, and I'll talk a little bit more about what we do a little bit throughout the presentation, because while there are many things that you could talk about around running thousands of websites, the thing that I'm going to talk about is the developer experience, the act of deploying websites, managing the infrastructure, uptime monitoring, things like that, which are in fact the exact things that Platform.sh looks after for websites. So we're a platform as a service where we look after the developer experience and deploying and running websites, which is how I came to this topic, because we end up with some customers who have thousands of websites, and we've seen that their challenges are quite interesting and unique and instructive around the art of running websites in general. So if you're in the audience and you have a lot of websites, that would be really interesting to hear from you, either throughout the presentation. Don't hesitate to interrupt me and ask questions. Just turn on your mic and blurt it out. I'm totally fine with that. Or at the end, and especially if you have even dozens or hundreds of websites in your organization, or that you're responsible for, or that you work on, that would be super interesting to hear your experience with that. And you can fact check me or bring me back down into reality if I say something that doesn't fit with your experience. That would be fine. But so who even has 1,000 websites? That, I think, for most normal mortal people, the very concept of being responsible for 1,000 websites or more, or even thousands of websites, is incredible. I would have never imagined that myself as a web developer when I was writing code for websites myself. We see a few categories, though, of organization that, in fact, easily go up to thousands of websites that they're responsible for. Let me just call out, for example, universities as being a very typical case. I think even worldwide, we've got a case with the University of Missouri, and their IT department has 2,000 sites that they manage. And the funny thing about universities and websites is that they very much follow the hierarchical and transient structure of universities. So universities have different schools: School of Engineering, School of Art, School of Business, and then they've got departments within those schools, and then they've got classes and professors and student groups, and all of the entire population of the university, except some of the professors, kind of resets itself and flushes out every 4 to 8 years. So the people who set something up 2 years ago aren't around to take care of it in 3 years down the line. So you've got websites that are literally running on computers under desks, plugged into the Ethernet network somehow, and nobody knows who built it, how they built it, why they built it, or whether or not it should be taken offline. And the IT departments have to rein that in. So that's one of the cases where we see thousands of websites easily. Another is really any type of company that is both international and has a large portfolio of brands, especially consumer-facing brands. I've got an example here from a life sciences company. They're localized across the many brands that they have, and we're talking hundreds of brands, they're localized to more than 50 countries and localities. So those are the main brand websites. In addition, they run a lot of campaign microsites. So maybe they're pushing a specific brand or reacting to events or trends, different demographics. So those generate new sites. And those are all regulated sites with compliance requirements. So it becomes very hard for them to manage that number of websites with all the requirements that go onto them around security, private data, legal requirements about talking about medicines or things that can affect your health. It's quite formidable, their challenge. I think we've learned a lot from working with this type of company. Similar, without so much compliance, we work with some companies that have international presences as consumer brands. You know, think large companies that you might be familiar with that make both diapers and nappies and chocolates and bottled water. Work with some companies that have thousands of sites. Again, it's usually the proliferation of many different products and then marketing those out into different territories with different localizations. And the interesting thing about that with these last two examples is that because they're international, they depend on developer teams who are local to the site that they're working on. So they've got a double governance challenge. They want to protect the brands or the compliance for their products at a central level, and maybe also the IT and the hosting and everything, but yet they still need to enable hundreds of development agencies around the world in different countries to work on these sites. So imagine the challenge of, you know, having digital agencies in Pakistan, Portugal, Czechoslovakia, Czech Republic, Slovakia, Germany, Hungary, UK, South Africa, Brazil. Every country you can think of has web agencies working on the sites that are locally, but they also have to be governed with central governance around compliance and IT and developer workflow. It must be really, really difficult. So those are the types of organizations that we've seen. I think there are others. Maybe you've got examples that you can bring up in the Q&A or along the way. Yeah, so how's this presentation work? I've come up with different vectors or categories where it's interesting to talk about the proliferation of these sites and what goes into making it possible to run that many sites. So development process, the coding standards and deployment, infrastructure, updates and maintenance, data, user access, developer access, and monitoring. And for each of those, I'm going to break that down a little bit further with very specific points and give you kind of a worst case to best case progression. So you'll understand when you see it. Let's do one. So let's talk about the development process. In specific, we're going to talk about onboarding and offboarding of developers, developer environments, and stakeholder engagement. So worst case in onboarding and offboarding developers. And sometimes the worst cases are fun because they come from actual life experience. And if you've had a life experience that is similar to some of these worst cases and you want to share your horror stories, I'm totally open to hearing that as well. But as a developer, I always thought it was frustrating if I had to install runtimes and services that are necessary for my development by myself, because then I had like no guarantee that they were going to be the same on the production or staging servers, and it was just a waste of time. As a developer, I also thought it was really fun, but maybe a little scary when I was given root access to production, because that's a lot of responsibility and it's not good governance. And if you scale that to 1,000, then you're dead. Anytime I had to download code, or somebody said, get the code off the server, or they sent the code to me in some way, that was always a red flag. And also, if you have 1,000 sites and any one of your developers who's not the CTO can actually develop on all of them, that's probably a red flag. So 1 star. And then I go up to a 2-star scenario. So I don't do all 4 stars for all cases, but this is the example, so I do. So slightly better than the first case is if you have a shared development server. If you can check out the code from Subversion, it's better than downloading it or getting it sent to you, copying it from the server. But yeah, it's still Subversion. And also, if the developer has to be added as a developer to every one of the sites manually, then that's going to be a lot of work for the people maintaining developer access. So getting better, 3 stars is also already really good. Maybe 3 stars is usually like best, like what you'd expect in the field these days. Like if I take a web development job, 3 stars is basically the minimum threshold of what to expect for good practice. And that is, as a developer, hey, give me Docker images. I'm gonna run those locally, or tell me which Docker images to use, and I'll get them, and I can do that, my development that way, so that I'm not setting up InfluxDB on my MacBook, right? Because I don't want to do that. If you provide me with a dedicated development server, that's also, a 3-star, pretty good signal that you've got your stuff together. If I can go into Jira and by closing my ticket or doing something, or substitute GitHub or GitLab for Jira there, and if I can trigger deployment by closing the ticket or signaling by some workflow tool that needs to deploy, that's already pretty good. Or if I can run a Jenkins task and add my whole team to the site, or add me to all the sites that I need to develop on, just some sign of automation for those tasks that are that pile up. Now, the good thing about the 4 stars is that you always get an amusing GIF to look at, which is exactly how you feel when you do it right. So enjoy the GIF. I think that in terms of like setting up onboarding and offboarding developers, if you could just go into GitLab and like add them to the team, isn't that like so natural? And or if you do Active Directory somehow, add them to the right team and let that percolate through all of the systems that they need access to, and voila. So I mean, that's kind of true for any organization that has a lot of people. I know it's true for our company, Platform.sh, that the onboarding of new team members is really hard to make seamless and painless, but it's totally worth the investment. When you add the new developer and they're able to clone the production site or the staging site or whatever they're supposed to develop on to their local machine, because they have a process to follow, something they can do that just does that, it's already a great sign. And if they can develop then on a Git branch and have that be testable some way, then this is a good sign that the scalability of your sites and your teams is going to work. And if you can like assign the team that they're on to the sites that they're working on, or the business unit that they're supposed to be working in, and therefore that controls the sites they can work on, great. So I'll go through them a little bit faster, or it'll get super boring, but that's the kind of the system we're using from worst to best. So next, developer environments. That's where the developer tests codes and tests, whether it's on their local machine or something that belongs to them in the cloud that's for developing and testing their code. So the worst of all is obviously just use whatever's on your laptop. I kind of already said that, but the problem with that is that the versions and the configurations of things, and by things I mean languages, runtimes, backend services, are not going to be the same. And you're going to get the "it worked on my laptop" syndrome. If you have to share a staging server, that's a bad sign for developer environments. We had a customer at one point who they were preparing their Black Friday website, e-commerce website, and they had two features that they felt were essential to getting through Black Friday with profit. One was the responsive theme, and the other one was coupons for their products. They could do sales and do incentives. And the coupons never launched, not because the developers didn't deliver on time, but because the responsive design was hogging the staging server and creating a bottleneck to testing the coupons. And the slowness of the responsive design development team actually prevented the coupons team from launching their feature. So if you have to share a staging server, not only is that a bottleneck, but it can be a case where you're stepping on each other's toes. And if you use the same types of development and staging environments for multiple sites, also probably a bad smell. It gets slightly better if I hear you talking about Vagrant or some of the older school virtual machine types of solutions. At that point, like, you roll your eyes and you're like, how do you start the fan on your MacBook? Ha ha ha. Oh yeah. Oh, from the command line. How do you start the fan on your MacBook from the command line? Haha, it's a Vagrant up, right? So it takes so much resource compared to Docker. Or if you have to like file an ops ticket to get your environment built, it's not going to scale. Pretty good practices when, like I said, Docker containers. It's even better if those Docker containers can then be deployed on a Kubernetes cluster, because that shows that you are thinking about things like scalability and replication, and looking for the way to update with disposable containers. And it's nice. Kubernetes is a good buzzword to hear when you're looking at how people are doing things. And it's also good if you've got like different customized Docker configuration for every site that you're working on. 4 stars on that one. So we work with a company and a tool called Lando that provides a local development environment. And this actually allows you to have a setup that's really automated and can let you switch between the sites that you're developing on really quickly, but have an experience that's as close as possible to what's going to be in production. You also want to be able to copy the production infrastructure for your sites for every testing operation, kind of with exact services configuration and data, so that you don't introduce problems in the testing workflow by inconsistencies. And when you have thousands of sites and all those developers, the chances of individual developers working on multiple sites at once is very high. So they need to be able to context switch very quickly and move their work between distinct environments for each of the sites that they're working on, and scale that across your fleet. Here's just a bit more about Lando. That's a new partnership and a new product announcement for Platform.sh, which is why I put an extra slide in here. There's a blog post on it there at the URL. But basically, it sets up a Docker-based local development environment using templates or recipes. And it integrates with, in this case, the cloud being Platform.sh, but other cloud solutions as well, to move the code and the database and the files that belong to your site between local and the cloud bidirectionally. So you can either synchronize from the cloud down to local, or move things back up from your development into the cloud in a very targeted and consistent way. And if all your developers are using a tool like that, then the developer experience is good and consistent, and everybody's, nobody's stepping on each other's toes. Good. So let's move on to stakeholder engagement. This is one that I think gets overlooked very easily, but is very germane to any organization that has 1,000 or more sites. I mean, it's germane to anybody who has a site. But when you have thousands of sites and you have stakeholders at many different levels, let's go back to, say, the university. You've got stakeholders who are the site maintainers. You've got to enable them as an IT department. You have to enable the student developers to maintain the site, or the faculty developers, outside developers, and you've got to also give the editorial staff their access, and then the people who depend on the site, like for class registration or information about student activities, those stakeholders have to give feedback. And it's really hard to coordinate stakeholder engagement through so many disparate groups if you're fighting with access. So, I mean, the typical answer to that then, of course, is show them on production, deploy things and say, hey, do you like it? And if they don't, then, well, it's already deployed, so what are you going to do? And I've seen this. I've seen cases where, not just where there are thousands of sites, but where the primary time for getting the important stakeholder information that you need is after you've actually deployed it. And that's just not good. Slightly better is the shared staging server, but the problem there is if you're showing somebody feature X, they're going to be distracted if they also see feature Y in a different stage of development. So you don't want that shared staging server. What's good in this case is if you can send the client a URL that demonstrates a specific feature on a specific site, segregated from all of the other things that you have in flight. That means that you've got to be able to have a runtime environment for that site, which could be very complex, for basically every feature that you're working on. And it has to be addressable remotely through a URL, and you should easily be able to send that. And I think the other points just say the same thing. So yeah, it's really important to be able to show your stakeholders the features as you're developing them, segregated from the others. The faster you can do that, also, the more quickly you'll get feedback from your stakeholders, and the better your developer teams will maintain the context of what they're working on. So just do a thought exercise as a developer or a designer or somebody working on a website, even a content author. It takes a lot of contextual thinking and awareness to get into the task of making a change on the website. Especially as a developer, I know that it always felt to me like I was crawling into a dark maze, groping around with my fingers, looking for a leaky pipe so that I could then blindly fix the pipe with tools that I had in my backpack. And if I had to go out and get something because I forgot a tool, then I would lose the context of where I was in the maze, and I'd have to grope around again with my fingers in the dark and the cold until I found the leaky pipe again. So that's just one way of saying, like, if you've got a developer who's just finished up a feature, get the feedback for that feature from your stakeholders as fast as you can, because if you wait too long, they'll lose the context about what they're working on, and it will slow them down when they want to get on with fixing the thing that you're asking them to fix. Right, let's move on. Coding standards. Okay, obviously for having thousands of sites, if they're all going to be coded and customized in some way, then the coding standards are going to be super important. So we'll talk about third-party libraries, code quality and testing. So third-party libraries. If you're just running a proprietary software as a SaaS, then this doesn't apply to you. But if you're in the group that has chosen any sort of either custom or bespoke development, or you're running open source packages of any kind, then you basically have to be at ease with the fact that a natural part of the development process is downloading half of the internet every time you build something. Just try it. Run NPM or Composer or Maven on any serious project and see the amount of code that gets downloaded from the repositories, from the open source code repositories across the internet. So you have to be able to manage that. And one of the ways that is bad to do that is if you just go to, if as a developer, go to a website like GitHub or SourceForge and download the zip file and unpack it into your code base and boom, done. That's 1 star. I jumped to 3 stars for developers who use a build system like Composer or Maven or pip, and files like package.json to get those and manage those dependencies, because these days you can't actually properly manage dependencies without a proper dependency manager. And you check the artifacts of those package managers, like the lock files that they generate, into Git. That's already a 3-star process. If you check those into Git and then the system applies a unified build pipeline across all the developer projects and actually runs the Composer install or the npm install commands consistently and maybe caches that as well for you, then that's good. I could tie in at this point to some of the future topics that I have about testing, that this is also a good opportunity to use services that look for out-of-date packages or security vulnerabilities in packages, because the good thing about the open source package management ecosystem is that it makes it achievable to track all of those packages and their maintenance state for known vulnerabilities, and having a step built into your pipeline that is automated when you download those third-party libraries that looks for those vulnerabilities and the updatedness. That's a good step, but I'll repeat that when we get to that bit. So in terms of code quality, this is, how do you get your developers to write good code? Well, that's really hard. It starts though with, it worked, therefore we deploy it. We've all been there. It worked, it's time to deploy it, boom. Though a really good workflow for code quality, as elusive and hard as it is to achieve, it would obviously involve unit testing. And if the tests fail, that would block your deploy. The step I talked about packages up to date should also block the deploy. Code linting, so that you follow actual just code standards where there are options. Use of blacklisted packages that goes along with the safety of your third parties. You also want to do regression testing, and there are lots of ways to do that. Performance testing, integration testing, and those are webinars on their own. I'm not going to get into it, but if I just talk a little bit about visual regression testing, then that's really fascinating, because if you have a web application or an application or a website of any kind, and you want to do visual regression testing, where you have things like the company logo must appear here and it must be blue, and you need to render the page to see it, how it's going to be, then that also says that you need an environment in which you can render the page, meaning for some applications, you need the entire database and all of the files and every service that goes into it, but you need it as a testing environment. So ensuring code quality through testing can be really hard and dependent on infrastructure. That's kind of my point there. Oops, sorry. I just bopped you in the head, metaphorically, through your ears. Some of these will overlap a little bit. So code deployment has several subtopics, but some of them we've already started to touch on. So here are the horror stories. So of course, if you're going to deploy code and you're using something like SFTP or USB sticks, or if you just like overwrite the files that are already on the server with the new files, then I have news for you. You're like, so 1995. But my favorite horror story here is I say USB sticks, but that's not even actually implausible. I have friends in Frankfurt, Germany who work for a bank, and they, to this day, to this very day, have to deliver the updates to the websites for this bank on a USB stick, and they come to the front door. They hand it to the person who looks at the doorman. They tell them the department to run it back to, and they sit in front of the vault, basically, where you can't go in anymore, and wait for the doorman to come back and say whether the deploy worked or not. It's wonderful. I would like a Netflix series just on that. So I've seen people do this a lot too, and that's basically SSH into the server and do git pull and get the latest from the remote Git repository. I'm not a fan of it, I have to say, because that means that somebody on the team, me or you or whoever, has the power to log into the server and change the code on the server. And that itself is a really bad thing, in my opinion. So that's why I don't think this is a very good idea, even though it's more consistent than just uploading the files via SFTP, because it's managed by Git, and you can roll that back and you can prove that you're deploying what you intend to deploy. But I still don't think it's very good. 2 stars. 4 stars is you push to your remote with Git, as we mentioned before, and that triggers a test environment deployment where the entire build process is replicated, the entire infrastructure is replicated. And then when you merge that Git branch in the remote to the, let's say, the master branch, that's what Platform.sh uses to deploy things. You merge that to the master branch, that triggers the deployment to production, but not through checking out the code onto the server, but rather by building an environment into containers that are purpose-built just for that deployment, and then routing traffic to those. And the last point here is interesting. The old environment is not updated, but replaced. And this goes to the very important concept of of throwing away your environments and your containers. So this is actually the first time I'm saying the word container in the presentation, but I think these days it goes without saying that a lot of best practice around deploying websites these days does involve containerized environments. I mentioned Docker, I mentioned Kubernetes. So containers are the basis of those technologies. And the best practice is to build your new version container and put it into production and start using it, and then throw away the old containers. Okay, you don't want to, in my opinion, try to update containers, because it's harder to update containers to the new state than it is to build a new container to the new state, and just use that instead. All right, how about speed and frequency of deployment? Obviously, faster is better, but in the vein of horror stories, I have seen it quite often where the people say, well, we update the site twice a year, and I'm not kidding. Now, this is getting a little less frequent to find these days because there's so many best practices that have come along, but once in a while, I find a customer who's got a website that gets updated twice a year. Step up from that, faster is better. At the end of each sprint, you deploy your website. So what are sprints? 3 weeks on average, maybe. So every 3 weeks, deploy to the site. Well, actual best of breed web properties like, I don't know, LinkedIn or Facebook or Amazon, you know, the people who do it really at scale, really, really big, they're deploying all the time. Every minute of every day, they're deploying something. They can deploy whenever they want, even when the site's under load, even on Black Friday. So that's the scale there. When you get to 1,000 sites, is that if you have to worry about when you deploy things, for technical reasons. It could be that you have to do it for other reasons. You have to worry about deployment schedules for other reasons. But if you also have to worry about deployment schedules because of technical reasons, then you're basically going to have a battle every time you need to deploy your website. And when you have a battle and you have a battle for one site and you've got 1,000 sites, then you're going to be spending all of your time battling your own organization about when or when not to deploy your sites. So best to have absolutely no technical barriers to deploying your site as often as you want, every day, if you want. Even on Friday, deploy Friday. That's our motto. All right, moving on. So deploying web applications is really funny and interesting because perfect is sometimes the opposite of good, where I'm defining good by meaning you can do it without incurring downtime. This is a funny topic for me to talk about coming from Platform.sh too, because I think we're perfect, but not always good. And I'll explain that in a moment. So I used to work in the Drupal project a lot, and the best practice for a long time was to put the site in offline mode when you deployed, because deploying would break a lot of things until it had run. So the way to do that would be to deploy the code and then run the update script so that the database was in synchronicity with the assumptions that the code was going to make about the database state. Yeah, well, that's 1 star these days. It's also technically necessary for a monolith like Drupal, and it's still the way it's done. CDNs help a little bit with the static content, but it's a hard problem. If you want a consistent web site and you've built your site in that way, then you kind of can't get around it. I skipped to 3 stars, and this is literally what Platform.sh does, is that we freeze requests during the critical phase when the database schemes are being updated. And when I say freeze, I mean we hold them at the edge layer, the Nginx layer, and they wait until the site has come back online and everything's updated and all the caches that need to be cleared are cleared and all the services have reported they're running. And then we play those requests so they don't actually hopefully get lost or time out, but they then go through when the update has done. And the CDN helps for static stuff. But I have seen talks about how to do, rolling updates on sites where even if you're doing database schema updates, you can use feature flags or put your columns in such a way that you can update your database kind of on the fly. Doesn't always work if you've got locking updates, and it depends on the database you're using. It can extend to many levels, but if you can do it, and the customers never notice that you deploy, and there's no downtime whatsoever, bravo, that's a really hard problem to solve, especially, like I said, with a monolith like some of the old content management systems or older e-commerce systems, which are still very popular. Then it's nearly impossible to do that perfectly safely with no downtime. So there's a compromise. And then the extension of this idea of deploying is then deploying to a fleet. Do you do it one site at a time? Or if you're running sort of multi-site, do you go through them one at a time and update each one like in a batch? What does it look like? And is it a push or a pull model? Like, if I have a list of sites, am I gonna update all of the sites that need the update for baby products? How do I do that? Do I have to group my sites in some central repository and then loop through them? Or do you automate it and make those lists with in some sort of database and run it from a Jenkins script? I'm going to suggest that if possible, you should build your sites in a way that they operate on a pull model, where they query their home base, okay, which could be a Git repository, periodically to see if there are updates. And if so, they should initiate a protocol for updating. Maybe for some sites, it's safe to just update them automatically, but probably the best practice here is to have updates trigger a test environment to be built for that site, and then alert the people who are involved with it to go look at it and maybe manually merge it. This allows then, of course, the updates to come organically. So there can be releases, sure, but the updates will be triggered anytime any package or underlying library gets pushed to a certain level to indicate that there are sites who are subscribed to that, who use it, who need updates. I don't have practical tips on how to do this outside of what we do for our clients at Platform.sh. So if you're in the audience and have some tips like Stefan Adolf about how to do this, or anybody else who has lots of sites, this would be something that, when we get to the end of my slides and I finish up, hopefully on time, we can talk about that. Somebody has I hear an echo, so somebody wants to talk. No, okay.
Sorry, I don't know if this was my echo, Robert. If you're talking about Docker repos, this is the way to go, right? So you push an image.
Absolutely.
And this one rolls out in canary mode from blue-green deployment. If something goes wrong, it rolls back. This is just amazing stuff, but it's not that simple to do.
Absolutely. Thank you. All right. Now, if you're going to deploy stuff, it could go wrong and you're going to want to roll that back. So the enemy here is if the old site has completely gone away, or if there's no way to go back. If it's a one-way street, then that's 1 star. If you're reassuring yourself that there is a backup and you're not thinking about it very much, then you're going to have problems at some point, because who knows where the backups are, who knows how to deploy, to bring them back in. And have you tested that? Have you actually really tested rolling back your site? So blue-green, as Stefan just mentioned, is one way to manage rollbacks. That's for kind of the moment of deployment. So that means that you bring up the new version of the site, but the old version is still taking traffic, and you progressively put more traffic onto the new version, detecting any problems as they come, and you can either then shape the traffic back to the old site, or eventually the traffic's on the new site and you throw away the old site. But even then, how long do you keep the old deployment around, and how are you doing it? Like, I used to see people symlinking the new code base on the servers, and then they switch the symlink and that deploys the site. It's kind of sloppy. Yeah, so I mean, what we see our customers needing and doing is that, these days, and I haven't mentioned this point yet, and it strikes me I should put this earlier, the infrastructure component about deploying is really important, and the best practice here is definitely to have a paradigm where you're versioning your infrastructure deployments along with your code base, because then your code base is specifying not only the application behavior, but also its infrastructure requirements. And the build system that you're using should be able to provide what's needed for the application to run based on what it sees in the code base. So this is infrastructure as code. Therefore, you put the power of rolling back any bad deployment into the realm of Git, which has natural tools for reverting things. So if you have a deployment paradigm and you feel that you need to roll back code and the infrastructure that's needed to support it, if you've made an infrastructure change, then the tool that you really want to use is Git revert. You want to go and revert the commit that you made, the merge that you made, and bring back an earlier hash or commit from Git, and that would specify the code and infrastructure needed for that earlier version. That doesn't handle the data though, and rolling back a deployment can only be done properly if you have perfect snapshots of your application data. And applications these days are very data-driven and therefore very complex, might have many, if not dozens, of data sources. And if the ones that are implicated in the deployment aren't snapshotted, then you could end up with corrupted data. Let's say I roll out my deployment, I run my database update scripts, and then I figure out I have to roll back. At that point, I have to replace my database from a snapshot. Good, let's move on to infrastructure. I think I got to pick the pace up a little bit. So ease of provisioning, ops tickets, no. Yeah, let's skip that. That's bad practice. VMs and Ansible and Puppet, you can still do great things with that, but Docker repositories are definitely, for most people, in most cases, the way to go. But the golden standard here is to define your infrastructure in code that you can manage alongside your application code. And the infrastructure should automatically adapt then based on the code that you push, because you're defining the infrastructure in code and it builds itself automatically. And you should be able to do that so easily that it's basically a click away. Okay, you should be able to experiment with your infrastructure by putting something else in code. And the easier this is, the better. Like the more simple the syntax is, the better. The fewer lines of code that you need for spinning up new services or routes or caching rules at the load balancer, all of that. The less code, better, because then you can really experiment. You can try out new things. You can stay modern and up to date and avoid being mired down by the inertial momentum of your project. Right, scalability, that's another topic. In terms of versioning, obviously no versioning is horrible. You definitely are going to be looking for obeying some sort of template when you're versioning your infrastructure, whether that's Ansible, Puppet, Terraform, anything else. It should be something that you can edit and then roll back and Git, as I mentioned. And you should be able to look at that template and deduct the version of the infrastructure, because another thing that I've seen a lot of when we're talking about lots and thousands of sites is that the audit of these sites to make sure that they're all running modern versions and stuff is really hard. It becomes a super big problem when you've got a lot of sites to audit them. Yeah, so best practice is when infrastructure is strongly linked to a specific deployment. So I deploy the application code and that provides the perfect infrastructure for that version of the application. I build everything new every time I deploy and throw away the old versions. And the whole thing, the application and the infrastructure, is linked strongly to a Git hash, so that if I want to roll that all back, I just have to use the tools that Git offers. I'm going to skip a couple things because we're super running behind. I just talked really slowly and I still want to leave some time for questions. So isolation on the server. Obviously, this is something that virtual machines and containers are meant to take care of. Disaster recovery for thousands of sites. Just imagine that you've got 1,000 sites and you host them all in one Amazon region and that region goes down. That hasn't happened for a long time. You need to be able to automate the replacement of your failed infrastructure, even if it's in a different location, because sometimes the problem that you're facing in a disaster is the location of your servers, literally. So you need to be able to move that around. When things move, you need to be able to move the data as well, and that can be big and bulky and hard. API driven, obviously, same process applied to 1,000 sites. And you need to look at the underlying capacity guarantees of your cloud provider. If it's like a public cloud provider, you need to choose one that has a lot of servers, so that if something does happen, like a region goes down, then the extra demand from customers trying to escape that disaster won't dry up the available resources. So that's a little bit hard to mitigate without just gravitating towards the largest players in the field. Immutable, that's the word that I was not using but referring to when I was talking about the idea of building things and then throwing them away. The underlying principle of that is that when you deploy something, you don't want it to be able to be changed. You want to remove the ability to change something that you've deployed. To change something that you've deployed, you should literally have to redeploy. That's an opinion. That's the dogma behind Platform.sh. That's why I carry that opinion. But the idea is that your code, once deployed, shouldn't be changed. The infrastructure shouldn't be changed. You should know very, very, very precisely what you have deployed, because nobody can go in and just fix it or change it or experiment with it or hack it. And the whole principle there is the immutability. So you want read-only file systems and you want disposable builds. We talked about infrastructure rollback. And I'm looking, we're coming up to the top of the hour. We talked about upstream security, so I'm going to move past that. So auditing, maybe I'll call this the last topic. This checklist does go on for quite a while still. Auditing is a really hard topic. You get a lot of questions like, you know, are my sites PCI compliant? Well, what are you going to do? Are you going to literally test on a quarterly or semi-quarterly or annual basis 1,000 e-commerce sites if that's what you're running? That's super expensive and super laborious. It would be much better if you could test a handful of them and then convince your auditors that the other ones are adhering to the same standards because they're all built in the same way and they're immutable and they're consistent. But how do you answer those questions? So the good thing about putting infrastructure and code together, and the good thing about using package managers, and the good thing about putting a version checker for your packages into the build process is that your auditing then becomes a matter of checking the build artifacts, which can be done quite easily with tools like grep, and finding out if you have vulnerabilities in your build packages. And then you and the auditors can have assurance, because you know how the system works and you know that your file system is immutable, that that's actually what's deployed. And you can save a heck of a lot of money and time on auditing if you can automate the audits of your sites in that way.